high-temperature vessels, such as those used in nuclear power reactors or oil desulfurization towers, are usually lined with stainless steel, which excels in resistance against corrosion. And a new overlaying welding process has been developed. It is called the Maglay process. It is a new overlaying welding process using a wide strip electrode and featured with adoption of electroslag welding and control of liquid slag and metal flow by electromagnetic force. The Maglay process promises higher quality welds and better productivity than the conventional arc welding method. How is the wide strip electrode overlaying welding done? Let us look into the details. As the figure shows, it utilizes heat of the molten slag generated by electric resistance. The Maglay process shown on the right has better penetration characteristics of base plate than the conventional SAW, opening the way for use of 150 millimeters or wider electrodes without slag inclusions or lack of fusion. What makes the Maglay process outstanding then? The epoch-making idea is the provision of electromagnetic coils on both frontal sides of the electrode, whose magnetic fields act on the welding current to prevent undercutting and flatten the weld bead. Now let's see an actual application of the Maglay process. A conventional SAW strip electrode welder can be turned into the new system by a simple improvement on its contact jaw for attaching the lateral coils. Magnetic control is started by exciting the coils. The electrode now in use is 150 millimeters wide. Watch the flow of the weld pool, and this is the secret of the excellent performance of the Maglay process. The flow of the weld pool is clearly seen from the surface pattern of the welding bead. Now, what will happen if the coil on the right is to remain idle? As you can see, molten slag flows anti-clockwise. The undercutting on the right side shows how effectively the magnetic control had been working. Next, an end plate welding is demonstrated. In the meantime, let us take another look at the merits of the Maglay process. Welding efficiency has drastically been raised through application of wider electrodes, not only 150 millimeter wide ones, but even those as wide as 250 or 300 millimeters. Here are examples of electrodes ranging in width from 25 to 250 millimeters. The electrode thickness is 0.4 millimeter. The bead thickness can be adjusted between 3 and 6 millimeters, depending on the welding condition. Look at the beautiful overlapping area between two passes of 150 millimeter wide welding. Welding by the Maglay process has no slag inclusions or lack of fusion. Bead dilution by base metal is on a low level. That is, the weld is little affected by the base metal. The smooth overlapping area between the welding beads causes no undercutting. Hence, the Maglay process promises a drastic reduction in repair welding and economy of materials, time and labor. Also, the welding beads have superior anti-corrosiveness due to their low oxide contents. In this way, highly efficient and reliable welding has been made possible by the Maglay process. Among the best applications of the Maglay process are manufacturing of pressure vessels for nuclear power reactors, oil refining reaction towers, heat exchangers, nozzles and flanges, and liners for water turbines. Numerous users are already enjoying the merits of the outstanding welding process. Here are the electrodes produced by Kawasaki steel. Any kind of welding for reactor vessels can be welded by means of these electrodes and the flux. The epochal wide electrode overlaying welding process Maglay has been developed by the technical staff of Kawasaki Steel Corporation. Kawasaki Steel presents the Maglay process with confidence as one of the newest techniques for the 1980s.